Okay, so let's go ahead and look at another rational function. First step again is to find the x-intercepts. What would make the numerator equal 0? In this case, x squared minus x minus 6 factors to be x minus 3, x plus 2, which means that x is equal to positive 3 and x is equal to negative 2 are the x-intercepts. Go ahead, add those to your graph. Now we should be able to find the vertical asymptotes. These are what would make the denominator equal 0. In this case, it would only be negative 1, so x is equal to negative 1 is the vertical asymptote. Go ahead, draw on your dashed line. And of course, we want to label x is equal to negative 1. Perfect. Moving on to the oblique or horizontal asymptotes. In this case, the numerator is 1, or the degree of the numerator, is 1 larger than the degree of the denominator. So this is going to be an oblique asymptote. To do the oblique asymptote, we do long division, just like we would do with our normal numbers. So we'd have x squared minus x minus 6 divided by x plus 1. Now, when doing long division, you always want to, first of all, make sure that there's a placeholder in everything underneath. So we have an x squared, the next term would be an x, and the next would be a 6. If you're missing anything, make sure you put a placeholder there of 0. Now, just like when we do long division with normal numbers, we want to see how many times does this, the x, go into x squared. What do we need to multiply x by to get x squared? Well, we would need to multiply it by x, so we put an x up here, and then we multiply everything through. So x times x is equal to x squared. And then we have x times 1 is equal to just positive x. Like with long division, we go ahead and subtract everything. X squared minus x squared cancels. Negative x minus another x is actually negative 2x. Be sure to remember that you're subtracting. And then we carry down this negative 6. And we repeat the process. What do we need to multiply this x by to get negative 2x? Negative 2. Negative 2 times x is negative 2x. Negative 2 times 1 is negative 2. Go ahead and subtract everything. Negative 2x minus a negative 2x cancels. Negative 6 minus negative 2 is actually adding 2, so you get negative 4. Now, x is technically too big to go into negative 4, so we can't go any further. That negative 4 would actually be our remainder. But the only thing we care about with oblique asymptotes is the quotient, so y equals x minus 2 is the oblique asymptote. Let's go ahead. That would be a straight line with a y-intercept of negative 2 and a slope of 1. Obviously on your own paper, you can go ahead and use a straight edge. Make sure your line looks straight. I tried the best I can on here, but yours can definitely look a lot better than that. Now let's go ahead and see if, trying to shrink this a little bit, if the oblique asymptote gets crossed by our function. So we're looking if it crosses. We set our original function, the x squared minus x minus 6 divided by x plus 1. We go ahead and we set that equal to the equation of our asymptote, which in this case is x minus 2. When I multiply both sides by x plus 1, I get x squared minus x minus 6. Foiling x minus 2 times x plus 1 on the right-hand side, I actually get x squared minus x minus 2. Well, if I take away an x squared from both sides and add an x to both sides, I get the equation negative 6 is equal to negative 2. This does not ever work, which means that the asymptote will not be crossed by the function. The last step would then be let me erase some of this down here. Okay, so the last step would be to create the interval chart using the critical points, which in this case were -2, -1, and 3. We'll test -3 in this interval. We'll test -3 halves, which is -1.5. In this interval, we'll have our intercept, our y-intercept, because we will test 0. And then in this interval, we will test 4. Move everything up just a little bit so I have some room to write. So if x is equal to -3 after plugging everything in, I get that y is also equal to -3. So it's going to be below because it is negative. When x is equal to -3 halves, y is actually going to equal +9 halves, which is positive, so it's going to be above. When x is equal to 0, y is going to equal -6. So it's negative, which means it's going to be below in that entire interval. And then finally, when x is equal to 4, y is equal to 6/5, which is positive, so that for that entire interval, the graph should be above the x-axis. Going ahead and putting in the points that will work. For example, -3, -3. Let's see, 1, 2, 3, 1, 2, 3. Perfect. Go ahead. We know everywhere in that it's going to be below, and again, the graph always tries to get as close as it can to the asymptotes. -3 halves, 9 halves would be about 4.5. 0, -6. 1, 2, 3, 4, 5. It's right about there. And then finally 4 and 6/5, so just above 1. The graph is never going to cross any of the asymptotes, so it makes that general shape.